October 1st, 1943, Willow Run, Michigan. The factory does not sleep. It breathes. Steel ribs shudder as overhead cranes slide on rails. Rivet guns chatter like insects in summer heat. The air smells of oil, hot aluminium, and cigarette smoke soaked into wool coats. Beneath a ceiling that disappears into steam and shadow, a silver aircraft nose inches forward, not pulled, not pushed, but carried by the building itself. A B-24 Liberator bomber is being born. You stand on the concrete floor as it moves past, slow enough to touch, fast enough that no one can stop it. Men and women in coveralls lean in, hands already raised, tools poised. One team installs wiring looms. Another seals fuel tanks. Further down the line, wings wait, complete, painted, armed, ready to be bolted on like limbs. This bomber will be finished in less than 24 hours. Across the Atlantic, German radar operators track incoming Allied formations and believe they are winning. U-boats still sink ships. Flak still tears holes through aluminium. Fighters still claw bombers from the sky. But here, in a flat stretch of Michigan farmland, the war has already turned. At the edge of the line, watching without ceremony, stands a thick-set man in a dark suit. No uniform, no medals. His tie is crooked, his shoes are scuffed with factory dust. He does not raise his voice. He does not salute. Charles E. Sorensen, known to everyone simply as Cast Iron Charlie. He is not a general. He has never fired a gun in combat. But what you are witnessing, the relentless, unstoppable forward motion of American air power, exists because of him. Sorensen steps closer as the fuselage passes Station 21. He watches a young woman drive a rivet half a second slower than the rhythm demands. He does not scold. He taps his watch once, gently, and points at the moving chalk line on the floor. She nods, adjusts, keeps pace. The plane moves on. The chalk line never stops. This is not how aircraft are supposed to be built. Before the war, bombers were crafted, not produced. They were assembled in place, teams circling a static airframe for weeks, sometimes months. Skilled hands, slow progress. Every delay is acceptable because before 1941, time was something America believed it had. Germany did not build planes this way. Neither did Britain anymore. But America's aircraft industry, scattered and conservative, still clung to methods better suited to workshops than war. Sorensen had spent his life destroying that way of thinking. 25 years earlier, he had stood in another factory, watching Model T chassis slide forward on a moving line. He had helped perfect the idea that work should come to the man, not the man to the work. That speed was not chaos, but discipline. That precision could be now. As German bombs fall on England and Luftwaffe fighters slash through bomber streams, Sorensen has brought that idea here, to Willow Run. The Liberator nose reaches the end of the line. An inspector checks the last seal, signs his name in grease pencil, and steps back. The bomber rolls forward again. Out of the factory, into daylight, onto the runway. Engines will be mounted, fuel will be loaded. Within days, this aircraft will be crossing the Atlantic. Somewhere over Europe it may be destroyed. Sorensen knows that. Everyone here knows that. That is why the line cannot stop. Behind him, a clock mounted high on a steel column clicks forward. Another bomber enters Station 1. Another set of hands rises. Another aircraft begins its short, violent life. What Germany does not yet understand, what no pilot under flak-filled skies can see, is that the war is no longer being decided solely by courage in the air. It is being decided by minutes shaved from assembly steps, by tools rearranged, by workflows redrawn in chalk and steel. That is the theory. Destroy the factories, starve the front, but here, in America, production has become something else entirely: fluid, distributed, resilient. A target that cannot be fully destroyed because it is not built around heroics or individual brilliance. It is built around systems. Sorensen turns away from the line and walks towards a glass-walled office overlooking the floor. Inside, engineers and managers argue over diagrams pinned to corkboards. A stopwatch ticks on a desk. A chalkboard lists numbers that change every hour. Output defects. This is not glamorous work. It will never be painted on a crude, but by the end of the war, it will matter more than any single dog. And it begins here, on a moving line, where one civilian factory manager has quietly found a way to build bombers faster than Germany can destroy them. December 7th, 1941, Dearborn, Michigan. The radio crackles in the corner of the office. At first, the words don't register. Static, distance, disbelief. Then they land, heavy and unmistakable. Japanese aircraft have attacked Pearl Harbor. Charles Sorensen does not move. Around him, Ford Motor Company executives freeze mid-sentence. A secretary's hand flies to her mouth. Outside the window, the River Rouge complex stretches for miles. Blast furnaces, assembly halls, rail spurs, an industrial city already capable of building almost anything. Sorensen understands something immediately that others do not. It will be won by time. Within hours, Washington begins calling. The Army Air Forces want aircraft. Thousands of them, not eventually. Now. Bombers large enough to cross oceans, fast enough to survive flak, complex enough that no single factory operating the old way can possibly meet demand. When Sorensen arrives in Washington days later, he listens as generals talk in terms of squadrons, sorties, attrition rates. He hears the fear beneath the confidence. America's aircraft industry is skilled, yes, but fragmented, slow, artisanal. AB-17 takes weeks to build, AB-24 even longer. Germany is already producing aircraft at scale. Britain has reorganized under fire. America is behind. Sorensen waits until the room empties, then lays his proposal on the table. You don't need better workers, he says. You need a better system. What he proposes is radical, borderline heretical to aviation engineers. He wants to treat bombers like automobiles, break them into standardized eliminate custom fitting, design parts so they can be installed by semi-skilled labor, move the aircraft through the factory, not keep it stationary. The objections come fast. Aircraft aren't cars. Aluminium isn't steel. Precision will suffer. Safety will suffer. Pilots will die. Sorensen listens, then responds with a single question. How many pilots will die if we don't build them fast enough? Silence follows. By early 1942, the government gives him what he asks for: authority without interference, land near Detroit, and a mandate to build Liberators faster than anyone believes possible. The location is Willow Run. 1,600 acres of farmland, mud, and snow. Construction begins immediately. The building will be nearly a mile long, the largest factory under one roof in the world. Inside, Sorensen begins dismantling aviation tradition piece by piece. He abolishes fixed-position assembly. He redesigns tooling so that he insists that engineers spend time on the factory floor, stopwatch in hand, watching how work actually happens, not how blueprints assume it happens. Every motion questioned, every delay attacked. When a mechanic complains that a job just takes that long, Sorensen asks why. When the answer is habit, the habit is broken. When it's physics, the design is changed. Most controversial of all, he brings in people who have never built aircraft at all. Auto workers, housewives, farmhands, teenagers. They are trained not to understand the entire bomber, but to master one task perfectly. One seam, one panel, one sequence of bolts. Skill becomes modular, replaceable, scalable. Mistakes spike at first. Planes fail inspections. Engineers panic. Sorensen does not slow the line. He speeds it up. Errors are not hidden. They are traced backward through the process. The station that caused the defect is reworked. The tool is redesigned. The instruction rewritten. The worker retrained. The system learns. By mid-1942, Willow Run is producing one B-24 per day. By early 1943, it is 2, then 3. Across the Atlantic, German intelligence notices the numbers but dismisses them as propaganda. No factory, they believe, can sustain that pace. Strategic bombing will... They are thinking in terms of buildings. Sorensen is thinking in terms of flow. When a fire shuts down one section of the plant, production reroutes. When parts lag, suppliers are reorganized. When aluminium shortages loom, substitutions are engineered before the crisis hits. There is no single point of failure because there is no single point of genius, just process. At a briefing in Washington, an Army Air Forces officer asks Sorensen how long Willow Run can maintain output under bombing conditions. Sorensen answers calmly, "You can't bomb a method." By late 1943, American bomber losses over Europe are horrific. Schweinfurt, Regensburg. Hundreds of aircraft destroyed. Thousands of aircrew killed or captured. German commanders believe they are winning. They do not see Willow Run. They do not hear the rivet guns. They do not understand that every bomber they shoot down has already been replaced. Sometimes before the wreckage hits the ground, the chalk line keeps moving, and somewhere between Station 14 and Station 15, the balance of the air war is shifting, not in the sky, but on the factory floor. August 17, 1943, 25,000 feet over Schweinfurt, Germany. The bomber formation stretches for miles, silver shapes glinting in the sun. Inside a B-17 named Royal Flush, oxygen masks hiss softly as engines drone at full power. Below, the German countryside slides past in patchwork greens and browns. Then the flak begins. Black bursts bloom ahead of the formation, precise and deliberate. The Luftwaffe knows this target well. Ball-bearing plants critical to every German engine, every tank, every aircraft. If these factories are destroyed, American planners believe, the German war machine will seize up. That is the theory. The gunners brace as Focke-Wulf 190s tear through the formation. One bomber spirals down trailing smoke. Another explodes mid-air. The sky fills with violence, metal. Back in England, planners mark losses with grease pencils. Back in Germany, Albert Speer watches smoke rise from shattered buildings and believes, briefly, that industry can be strangled from the air. But thousands of miles away, in the American Midwest, a different lesson is unfolding. At Willow Run, no sirens sound, no bombs fall. But Sorensen studies reports from Europe with the same intensity as flak maps. He sees something others miss. Germany is trying to defend places. America is building. Strategic bombing assumes production is centralized, factories fixed in place, dependent on specialized workers and fragile supply chains. That assumption had been true once. It is no longer true here. By late 1943, Willow Run is only one node in a vast network. Subassemblies arrive from dozens of plants across the country, wings from one state, fuselage sections from another, electronics from a third. If one supplier stumbles, another fills the gap. When a rail delay threatens output, parts are trucked. When a design flaw appears, it is corrected across every line simultaneously. When experienced workers leave for military service, the system absorbs the loss. German bombers cannot reach Michigan, but even if they could, Sorensen knows the truth. Destroying a building does not destroy a method. At a war production board meeting, an officer raises concerns about morale. The public sees bombers shot down over Europe. Casualties mount. Can American industry keep pace emotionally, not just materially? Sorensen responds without sentiment. Morale follows success, he says, and success follows output. By early 1944, American factories are producing aircraft at a rate Germany cannot comprehend. A B-24 every 55 minutes. Nearly 100,000 aircraft in a single year. Losses absorbed, replaced, exceeded. German pilots notice something terrifying in the skies over Europe. Formations that seem endless. Shoot down one bomber, and another fills the gap. Break up a group, and escorts arrive in force. This is not bravery alone, it is arithmetic. In Berlin, Speer orders dispersal. Factories broken into smaller sites, hidden underground, spread across forests and mountains. It works, partially. Output recovers. Germany survives longer than expected. But dispersion costs efficiency. America does not need to disperse. It has already industrialized resilient. At Willow Run, Sorensen walks the line as he always does. The chalk markings have been repainted dozens of times. Stations have been added, removed, rebalanced. The factory no longer resembles the one he opened a year earlier. It is faster now, smarter, almost alive. A foreman approaches with a problem. A recurring delay at wing installation. The solution would once have taken weeks of meetings. Sorensen solves it in minutes. Repositions a tool rack, reassigns 2 workers, adjusts timing by seconds. The delay vanishes. In the sky over Germany, bombers continue to fall. Men continue to die. But the math has turned brutal. For every aircraft Germany destroys, America replaces 2, then more. And for the first time, the Luftwaffe begins to feel exhaustion, not of pilots, not of fuel, but of inevitability. They are fighting a machine that does not tire. February 20th, 1944. Big week. Across the skies of Nazi-occupied Europe, the air war reaches a new intensity. Allied planners call it the crews call it something else entirely. Big week. Day after day, bomber streams cross the channel, deeper and farther than ever before. Aircraft factories, airfields, engine plants, the heart of German aviation. Inside a P-51 Mustang, Lieutenant James Howard scans the horizon. He has escort duty today, long range, all the way to Leipzig and back. Below him, the bomber formations look endless, staggered in altitude and direction, overlapping fields of fire. This is new. A year ago, bombers flew alone for much of the journey. Now fight not because of a sudden breakthrough in tactics, but because America has built enough aircraft to make it possible. Every decision in the air traces back to decisions made on the ground. At Willow Run, the line runs faster than ever. The war has matured, and so has the system. Output targets are no longer aspirational. They are expected. Misses are investigated like crimes. Improvements are shared across plants nationwide. Sorensen no longer needs to shout. The factory thinks the way he thinks now. A young engineer proposes a change to fuselage jig alignment, saving 30 seconds per aircraft. 30 seconds multiplied by thousands becomes days. Days become squadrons. Squadrons become air superiority. This is how the war is being won, not with a single invention, but with relentless accumulation. In Germany, the contrast is brutal. Factories disperse into forests, caves, tunnels. Skilled workers are drafted or killed. Slave labor fills the gaps, untrained, exhausted, sabotaging machines when they can. Output continues, but quality suffers. Engines fail early. Airframes crack. Replacement parts don't fit. German pilots climb into aircraft they do not trust. American pilots climb into aircraft built by systems designed to catch mistakes before they reach the runway. During Big Week, losses are heavy on both sides. But something irreversible happens. The Luftwaffe comes up to fight and does not recover. Fighter groups are destroyed faster than they can be rebuilt. Training pipelines, fuel shortages ground what remains. Germany still has factories, still has blueprints, still has ideas. What it no longer has is time. Back in Michigan, Sorensen receives reports from Europe not with celebration but calculation. Loss rates, replacement rates, sustainment curves. The numbers are clear. America is now producing more aircraft than it is losing. Even at the peak of combat, strategic bombing has not destroyed German industry outright. Instead, it has forced Germany to fight an industrial war it cannot mathematically win. And the decisive factor is not explosive yield, it is throughput. By mid-1944, Willow Run reaches its peak, a completed B-24 every 63 minutes. The factory produces more heavy bombers than Germany produces fighters combined. Sorensen walks the line one final time before turning more authority over to his successors. He stops near the end, watching another Liberator roll into daylight. Victory, to him, has never been emotional. It has always been mechanical. The bomber lifts off, banking slowly into the sky. Somewhere over Europe, it will face flak and fighters. It may not return, but another already waits behind it. And another. And another. The war has become an equation Germany cannot escape. May the 8th, 1945, Dearborn, Michigan. The radio announcement is brief, almost understated. Germany has surrendered unconditionally. Outside, church bells begin to ring. Car horns blare along Michigan Avenue. Workers spill from factories into the streets, laughing, crying, embracing strangers. Somewhere, a man climbs onto a car roof, waving a flag he's kept folded for years. Inside a modest office not far from the River Rouge complex, Charles Sorensen listens in silence. There is no cheering here, no ceremony, just a man at a desk, hands folded, staring at a wall map of Europe now marked with pencil lines and dates that have finally stopped moving. For Sorensen, the war did not end today. It ended months ago, when the numbers became irreversible. By late 1944, German aircraft production still existed on paper, but not in practice. Factories produced planes without fuel, pilots without training, squadrons without replacements. The Luftwaffe had become a hollow force, incapable of stopping Allied bombers or even protecting its own cities. And the reason was not a single raid, not a single weapon, not a single hero. It was volume. American industry had achieved what no air force could destroy: dominance through repetition. Bombers replaced faster than they fell. Crews trained faster than they were lost. Entire air fleets regenerated continuously, like a living organism healing its wounds. Willow Run alone produced nearly 8,700 B-24 Liberators during the war. Across the nation, American factories delivered almost 300,000 aircraft, more than all Axis powers combined. Germany never came close. After the war, analysts would argue endlessly about strategy, about daylight bombing versus night bombing, about precision versus about whether strategic bombing worked. Sorensen had no patience for the debate. Bombing mattered, yes, but only because it forced Germany to fight an industrial contest it could not sustain. Every bomb dropped demanded a replacement. Every loss demanded output. And Germany's system, centralized, fragile, starved of labor and fuel, collapsed under the weight. America's did not. Because America had learned something older than the airplane, that wars are not won by moments, but by momentum. Not by brilliance, but by process. Not by heroic effort, but by systems that make heroics unnecessary. Sorensen never became famous. There were no parades in his honor, no movies made about chalk lines and stopwatch timings. His legacy lived quietly, in logistics manuals, in production theory, in the factories that would later build jets, rockets, and spacecraft. The methods refined at Willow Run would shape Cold War industry, space exploration, and modern manufacturing itself. Long after the sound of rivet guns faded, the idea endured. That efficiency is power. That organization is force. That the deadliest weapon of the Second World War was not a bomb or a bullet, but a factory that never stopped moving.